Take a deep breath and let the weight of the day dissolve into the surface beneath you, allowing your muscles to surrender to the pull of gravity. As you exhale, imagine your consciousness drifting north toward a land of obsidian and emerald, where the earth is still being born amidst the patient choreography of fire and ice. We begin our journey on the Mid-Atlantic Ridge, a massive underwater mountain range that marks the divergent boundary between the Eurasian and North American tectonic plates. Iceland is one of the few places on our planet where this rift rises above the ocean's surface, and as you stand here in your mind's eye, you are witnessing a slow-motion expansion. Every year, this island grows by approximately 2 centimeters as the plates pull apart, allowing molten magma to rise, cool, and create new crust. It is a young land, only about 20 to 25 million years old, yet it carries the rhythmic pulse of the planet's deep interior. Here, the water does not just flow, it narrates the history of the Earth's cooling. Consider the immense presence of Dettifoss, located in the Vatnajökull National Park in northeast Iceland. As you approach, you feel a low-frequency vibration in the soles of your feet before you even hear the roar. This is Europe's most powerful waterfall. It stands 44 meters tall, about 144 feet, and stretches 100 meters wide. But the true scale of its power lies in its volume. An average of 193 cubic meters of water plunges over the edge every single second. During the peak of the summer melt, this volume can swell to 600 cubic meters per second. Imagine the weight of that water, a heavy gray curtain laden with sediment, carved from the Jökulsá, a Fjöllum river. The water is a milky gray because it carries glacial flour, fine particles of rock ground down by the immense weight of the Vatnajökull glacier. As you stand near the edge, the mist brushes against your skin, a cool, damp veil that carries the scent of pulverized stone and ancient ice. The sound of Dettifoss is not a crash, but a continuous white noise hum that fills the frequency spectrum. It is a sonic blanket that isolates you from the rest of the world. In the physics of sound, this is known as broadband noise, and it has a profound effect on the human nervous system, signaling a state of environmental constancy that allows the mind to settle. You are safe in the presence of this giant. The air here is oxygen-rich and ionized by the sheer force of the falling water, making every breath feel lighter, cleaner, and more revitalizing. Moving south, we find ourselves at Gullfoss, the Golden Falls. Here, the Vita River, fed by Iceland's second-largest glacier, Langjökull, takes a dramatic turn. You might notice the unique structure of the falls. They drop in 2 distinct stages. The first stage is an 11-meter descent, followed immediately by a second, deeper plunge of 21 meters into a crevice that is 32 meters deep and 20 meters wide. As the sun catches the mist, it creates a shimmering golden hue, a phenomenon caused by the suspended glacial minerals reflecting the low-angle Arctic light. The canyon walls surrounding Gullfoss reach heights of 70 meters, acting as a natural amphitheater. You can feel the temperature drop as you descend toward the spray. The water itself remains a constant 0 to 4 degrees Celsius, a reminder of its recent life as solid ice. Consider the texture of the land surrounding these falls. Iceland is home to vast blankets of Rhacomytrium lanuginosum, or woolly fringe moss. Under your touch, this moss feels like a thick, springy carpet, sometimes reaching depths of 10 to 15 centimeters. It softens the harsh volcanic basalt, muting your footsteps as you walk. This moss is a pioneer species, one of the first to colonize the lava fields, and it can live for decades, absorbing moisture directly from the mist of the waterfalls. It is a vibrant silvery green when wet, turning a ghostly gray when dry, acting as a living hygrometer for the island's humidity. Now, we drift toward the southern coast to witness Skogafoss. This waterfall is a perfect rectangle of white water, 25 meters wide and dropping 60 meters. What makes Skogafoss scientifically fascinating is its placement. These cliffs were once the coastline of Iceland. After the last glacial period ended approximately 10,000 years ago, the immense weight of the ice caps vanished, causing the land to rise in a process called isostatic rebound. As the land lifted, the ocean receded, leaving these former sea cliffs behind. The waterfall now marks the boundary between the coastal lowlands and the highlands. Because of the consistent volume of spray produced by Skogafoss, it is famous for producing vivid single or even double rainbows on sunny days. The physics of these rainbows, the refraction and reflection of sunlight through water droplets at a precise 42-degree angle, creates a bridge of color that seems to terminate right at your feet. You might imagine the sensation of the spray. It is a fine aerosol, a cloud of water that coats your jacket in microscopic beads. The water of Skogafoss is remarkably pure, having been filtered through layers of volcanic tephra and basalt for years before emerging into the Skoga River. The river itself is home to a healthy population of salmotruta, the brown trout, which navigate these cold, oxygen-rich currents. Further west, we encounter Seljalandsfoss. This waterfall is unique because the cliff behind it has been hollowed out by erosion, creating a wide cavern. You can actually walk behind the 60-meter-tall curtain of water. From this perspective, the world is seen through a translucent, moving veil. The acoustics change instantly as you step behind the falls. The roar becomes a resonant boom, vibrating within the hollowed stone. The rock wall behind the water is slick with algae and moss, cooled by the constant shade. From here, you are looking out toward the Atlantic Ocean, the source of the moisture that feeds this entire cycle. The water falling before you is part of a grand loop, evaporated from the sea, carried by the Gulf Stream's warmth to the cold north, fallen as snow on the glaciers, and now returning to the earth in a graceful vertical line. Think of Svartifoss, the Black Fall, located in Skaftafell. It is not the largest waterfall, but it is perhaps the most geometric. It is framed by dark, hexagonal basalt columns, which look like the pipes of a great organ. This is the result of columnar jointing. Millions of years ago, a thick flow of basaltic lava began to cool. As it cooled from about 1,100 degrees Celsius down to the ambient temperature, the rock contracted. To relieve the internal stress, it cracked into these perfect, six-sided columns. Each column is a record of a slow, rhythmic cooling process. Standing before Svartifoss, you can reach out and touch the cold, smooth surfaces of these hexagons. They feel like polished stone, cold to the touch, their edges still sharp after thousands of years of weathering. This geometry inspired the architecture of the Hallgrímskirkja in Reykjavik, bridging the gap between geology and human expression. We must also consider Hraunfossar, the lava falls. These are unlike any others. Instead of a river falling over a cliff, the water here emerges directly from the Hallmundarhraun lava field. The water has traveled underground, flowing through porous volcanic rock for miles, filtered until it is crystal clear. It emerges in countless tiny rivulets over a distance of nearly 900 meters, trickling into the turquoise waters of the Vita River. The temperature here is stable, the movement of the water more of a gentle seep, than a violent crash. It is the sound of 1,000 tiny bells, a delicate counterpoint to the thunder of Dettifoss. This water is the lifeblood of the island. In Iceland, the kinetic energy of falling water is harnessed with incredible efficiency. Approximately 73% of the country's electricity is generated through hydropower, utilizing the relentless gravity of the glacial runoff. As you rest, imagine this energy, clean, cold, and eternal, flowing through the grid, lighting the distant homes of the coast. High above these falls lies the source, Vatnajökull. This is the largest ice cap in Europe by volume, covering about 7,900 square kilometers, which is roughly 8% of Iceland's total landmass. The ice has an average thickness of 400 meters, but in some places, it reaches 1,000 meters deep. Beneath this ice lie some of the most active volcanoes in the world, such as Grímsvötn. This creates a constant subterranean battle between heat and cold. The volcanic heat melts the bottom of the glacier, creating subglacial lakes that eventually burst forth in Jökulhlaups, or glacial floods. These floods carry massive chunks of ice down to the sea, where they wash up on black sand beaches like diamonds. As you lie there, feel the rhythm of this island, the slow rise of the land, the 2 centimeter per year stretch of the tectonic plates, the millisecond by millisecond plunge of the water over the basalt cliffs. Everything is in motion, yet it is a motion so grand and so steady that it feels like stillness. You are part of this cycle. The atoms that make up your body were once forged in the same stellar furnaces that created the minerals in the Icelandic soil. The water in your cells follows the same laws of physics as the Vita River. The air in your room is still and warm, a contrast to the bracing mineral-scented mist of the falls. But you can still feel that coolness in your mind, a refreshing clarity that comes from the observation of nature's rawest mechanics. The waterfalls of Iceland do not tire. They do not rush. They simply are, performing their duty to gravity and the sea. Let your heart rate synchronize with the deep, low thrum of the falling water. Let your breathing become as steady as the flow of the Skóga River. The earth is moving beneath you, the stars are wheeling above, and the water is falling, forever falling, in a beautiful silent dance of physics. You are safe. You are grounded. You are drifting into the cool, clear mist of sleep. Invite a sense of profound stillness into your limbs, allowing your breath to find its natural, unhurried tempo as we continue our exploration of this liquid landscape. While we previously observed the raw physical power of these falls, it is compelling to consider how the human story has intertwined with this geology for over a millennium. As the mist of the Icelandic highlands settles around you, picture the horseshoe-shaped majesty of Godafoss, the waterfall of the gods. This landmark, located in the Bardardalur district of North Iceland, measures 12 meters in height and spans a width of 30 meters. It is not merely a geological feature, but a site of immense historical weight. Records indicate that in the year 1000 AD, a law speaker named Þorgeir Ljósvetningagodi faced a pivotal decision at the Alþingi, Iceland's parliament. To symbolize the nation's official conversion to Christianity and to prevent civil strife, he traveled to this waterfall and cast his carved statues of the Norse gods, Odin, Thor, and Freyr, into the churning white foam. What you are hearing in the rhythmic splash of Godafoss is the echo of a cultural transformation, where ancient bronze and wood met the indifferent, cold gravity of the Skjálfandafljót River. The early settlers, who arrived primarily from Norway, beginning in 874 AD with Ingolfur Arnarsson, viewed these waters with a mixture of reverence and practical necessity. In the Landnamabok, or the Book of Settlements, written in the 12th and 13th centuries, the topography of Iceland is described with meticulous detail. The settlers understood the water cycle not through modern physics, but through survival. They recognized that the glacial rivers, or Jökulsá, were different from the clear spring-fed rivers, or Draga. The glacial waters were opaque, carrying the crushed remnants of mountains, while the spring waters were filtered by the earth itself, providing life to the nascent farms. Consider the legacy of the West Fjords, the oldest part of Iceland geologically. Here, the landscape is a library of stone, with layers of basalt stacked like the pages of a massive book. Within this region lies Dynjandi, often called the Jewel of the West Fjords. This waterfall is a masterpiece of geometric precision. It stands 100 meters tall and possesses a unique trapezoidal shape. It is 30 meters wide at its crest and expands to 60 meters at its base. The water does not fall in a single curtain, but cascades down 7 distinct tiers, each with its own name and character. The physics of this movement reveals the principle of laminar and turbulent flow. At the top, the water may move in smooth, parallel layers, but as it hits the jagged basalt tiers, the Reynolds number, a dimensionless quantity used in fluid mechanics, increases, causing the water to break into the chaotic, white noise spray that soothes the ear. What's happening now is a slow, silent dialogue between the water and the rock. The basalt of the West Fjords is approximately 10 to 16 million years old. Notice how the water has carved deep fjords and narrow valleys over these millions of years through a process called nick point retreat. As the water plunges, it erodes the softer sedimentary layers at the base of the fall, eventually causing the harder basalt caprock to collapse. In this way, a waterfall is never stationary. It is a traveler, slowly moving upstream at a rate of several millimeters to centimeters per year, leaving a canyon in its wake. History reveals that our understanding of these heights is constantly evolving. For decades, it was believed that Glæmur, located in Hvalfjörður, was Iceland's tallest waterfall, standing at 198 meters. However, the dynamics of the planet are never static. In 2007, a new giant emerged, as the Morsarjökull Glacier, an outlet glacier of the massive Vatnajökull, began to retreat due to warming temperatures. It revealed Morsarfoss. This waterfall now holds the record, with a total drop of approximately 228 meters. It is a reminder that the Earth is still revealing its secrets as the ice, which has held the land for millennia, slowly withdraws. Permit your mind to rest on the story of Sigríður Tómasdóttir, a woman often recognized as Iceland's first environmentalist. In the early 20th century, her family owned the land around Gullfoss. When foreign investors sought to dam the Vita River to build a hydroelectric power plant, Sigríður fought a legal battle that lasted years. Legend says she even walked 120 kilometers to Reykjavik on foot to protest, threatening to throw herself into the falls if the project proceeded. Because of her persistence, the contract was eventually canceled, and Gullfoss became a national monument in 1979. Her spirit is felt in the preservation of this site, where the water is allowed to follow its own path, rather than being diverted through turbines. The chemistry of this water is as fascinating as its history. The density of water is highest at 4 degrees Celsius, approximately 1,000 kilograms per cubic meter. In the subarctic climate of Iceland, the water in these rivers often hovers near this point of maximum density. As it plunges over a cliff, the potential energy is converted into kinetic energy and eventually a small amount of thermal energy. While the temperature change is negligible to a human touch, the physics of this energy transfer is a fundamental law of the universe. The water remains cold, oxygenated, and remarkably pure. Deep within the soil surrounding these falls, scientists use a method called tephrochronology to date the landscape. Each major volcanic eruption in Iceland's history, such as the Hekla 3 eruption around 1000 BC, left a distinct layer of ash, or tephra, in the earth. By examining these layers near waterfalls, geologists can determine exactly when a river changed its course or when a canyon was formed. It is a biological and geological calendar where a single millimeter of dark ash can represent 1,000 years of quiet accumulation. The year 1783 marked a catastrophic moment for Iceland's water systems. The Laki eruption, known as the Skaftaraldar or Skafta fires, released 14 cubic kilometers of basalt lava and an estimated 120 million tons of sulfur dioxide into the atmosphere. This caused a dry fog that drifted across Europe and altered global weather patterns. In Iceland, the lava flow actually blocked and diverted major rivers, creating new temporary waterfalls and forever changing the path of the water that flows toward the sea. The resilience of the land is evident in how it has recovered, with mosses and lichens slowly reclaiming the scorched earth over the last 2 centuries. Observe the way the sunlight, even in the late hours of the Arctic summer, interacts with the spray. This light has traveled 150 million kilometers from the sun through the vacuum of space, only to be scattered by a droplet of water from the Langjökull glacier. This scattering follows me theory, which explains why the mist of a waterfall looks so white and opaque. The droplets are large enough to scatter all wavelengths of visible light equally, creating that brilliant, clean glow that contrasts so sharply against the dark volcanic rock. The basalt itself is a marvel of chemistry, rich in magnesium and iron. When this lava cooled, it formed 2 distinct types of structures: the lower colonnade of thick vertical columns and the upper entablature, which consists of smaller, irregular, and often curved columns. You can see this clearly at Svartifoss. The entablature forms when water, perhaps from an ancient waterfall or river, seeps into the cooling lava, causing it to contract rapidly and unevenly. This creates a chaotic, a frozen fracture pattern that looks like the work of an abstract sculptor. The Icelandic sagas, composed in the 13th century, often mention the smoke of the land. In Old Norse, the word for smoke is reykur, which gives Reykjavik its name, the smoky bay. But this smoke was often the steam from geothermal springs or the persistent mist of waterfalls. The language of the sagas is still remarkably close to modern Icelandic, meaning that a child today can read the 1,100-year-old descriptions of these very same waterfalls. The word vatn, for water, has remained unchanged, a linguistic constant in a world of shifting ice. At this very moment, the water of the Skoga River is moving at a velocity determined by the slope of the land and the friction of the riverbed. As it reaches the 25-meter-wide lip of Skogafoss, it experiences a brief moment of weightlessness. This is a literal application of the law of universal gravitation, where every particle of water is pulled toward the center of the Earth at an acceleration of 9.8 meters per second squared. For the 2 or 3 seconds it takes the water to fall the 60 meters to the pool below, it is in a state of freefall, much like a satellite in orbit or a star drifting through the void. The waterfall is a loom, weaving the threads of the glacier into the fabric of the sea. It is a process that has occurred since the land first rose from the mid-ocean ridge. You are witnessing the Earth's circulatory system, a rhythmic, closed-loop cycle of evaporation, condensation, and gravity. Invite this sense of ancient, reliable repetition to settle into your bones. The history of the Earth is written in the movement of the water, and you are currently part of that narrative, resting in the cool, stable presence of the eternal falls. Allow the weight of these centuries and the precision of these physical laws to cradle you as you prepare to drift further into the quiet of the Icelandic night. Notice the way your weight distributes evenly across your bed, mirroring the way the vast Icelandic glaciers press down upon the volcanic crust with a steady, unwavering force. As we transition from the history of these falls into their intricate mechanics, imagine the ground beneath the island as a living, breathing entity. The tectonic plates, the North American and the Eurasian, are pulling apart at a rate of approximately 25 millimeters per year. To visualize this slow-motion departure, consider that this is roughly the same speed at which a human fingernail grows. In the time it takes for you to enjoy a single night's rest, the island has expanded by a distance invisible to the eye, yet fundamental to the planet's architecture. What's happening now is a demonstration of pure geometry at Waterfalls, located in the highlands. Here, the water of the Skjálfandafljót River plunges 20 meters into a basin framed by spectacular basalt columns. Picture these columns as a giant stony honeycomb. This symmetry occurs because the lava cooled with such uniform precision that it fractured into hexagonal prisms, most of which are between 0.5 and 1 meter in diameter. Imagine these prisms as the structural cells of the Earth, stacked side by side like the pipes of a silent subterranean organ. When you view these shapes, you are seeing the result of the Stefan Boltzmann law in action, the physics of how energy radiates away from a hot object. As the 1,100 degrees Celsius lava surrendered its heat to the Arctic air, it shrank and cracked, creating a pattern as mathematical and orderly as a crystal lattice. Consider the scale of Hyphos, the high waterfall situated near the volcano Hekla. It drops from a height of 122 meters, which is nearly the same height as the Great Pyramid of Giza. If you were to stack two statues of Liberty on top of each other, they would still barely reach the top of this aquatic curtain. The water travels this distance in about 5 seconds, accelerating under the constant pull of 9.8 meters per second squared. As the water descends, it experiences a transition from a solid sheet into a chaotic spray, a process governed by the Weber number, which measures the surface tension against the fluid's inertia. By the time the water reaches the bottom, it has shattered into millions of tiny spheres, each acting like a microscopic prism. Deep within the currents of Dettifoss, the water carries a heavy load of glacial flour. These are rock particles ground down by the weight of the Vatnajökull ice cap to a size of 0.002 to 0.06 millimeters. To understand this texture, imagine a spoonful of powdered sugar stirred into a clear glass of water. This fine silt is what gives the glacial rivers their characteristic opaque, milky appearance. The particles are so small that they do not settle. They remain suspended by the internal turbulence of the river, acting as an abrasive that slowly polishes the basalt riverbed over thousands of years. What occurs at the base of these falls is a demonstration of immense pressure. At the bottom of a 60-meter plunge like Skogafoss, the impact pressure of the water hitting the plunge pool can exceed 600 kilopascals. This is approximately 6 times the pressure of the atmosphere at sea level. If you were to submerge yourself to that depth in the ocean, you would feel the weight of the water pressing against your ears. Yet, in the Waterfalls basin, this energy is dissipated into foam and sound, creating a localized microclimate where the air is constantly churned and refreshed. Notice the sound as it travels through different mediums. The speed of sound in the cold, 4 degrees Celsius water of an Icelandic river is approximately 1,480 meters per second. This is more than 4 times faster than the speed of sound in the air around you. Within the water, the roar of the falls is a sharp, percussive series of clicks and pops as air bubbles are trapped and compressed. Above the surface, the air acts as a low-pass filter, softening the impact into the deep, bass-heavy rumble that you perceive as a soothing white noise. It is a sonic tapestry, woven from the vibrations of liquid hitting stone. Observe the way light interacts with the water. Pure water is not truly colorless. It has a very slight blue tint. This is because water molecules absorb light more efficiently at the red end of the spectrum, specifically wavelengths between 600 and 700 nanometers. The blue wavelengths, around 450 nanometers, are scattered back to your eyes. In the deep pools at the base of waterfalls like Waterfalls, this effect is intensified, creating a vibrant, celestial cyan that looks almost artificial. It is the same physics that makes the sky appear blue, a phenomenon known as Rayleigh scattering, occurring here in a liquid state. Scientists discovered that the water molecules themselves are incredibly ancient. Most of the water on Earth, including the droplets currently falling over the Icelandic cliffs, is approximately 4.6 billion years old. This water predates the sun itself, having originated in the interstellar medium before being gathered by the Earth's nascent gravity. As you imagine the water falling, realize you are watching a substance that has been recycled through the hearts of volcanoes and the lungs of ancient forests for eons. It is a persistent, nomadic element, currently pausing its journey in the North Atlantic. Picture the volume of the Vatnajökull glacier, which feeds many of these falls. It contains roughly 3,100 cubic kilometers of ice. If you were to spread this ice evenly across the entire United States, it would cover the land in a layer 30 centimeters deep. This massive reservoir of frozen potential energy is what sustains the eternal flow. Every summer, the sun provides the latent heat of fusion, 334 joules of energy for every gram of ice, to turn that solid white expanse into the rushing rivers of the lowlands. The density of this ice is another curiosity of physics. Ice has a density of about 917 kilograms per cubic meter, while liquid water at 0 degrees Celsius is approximately 1,000 kilograms per cubic meter. This 8.3% difference is the reason ice floats. In the Jökulsárlón Glacier Lagoon, where the meltwater from the falls eventually gathers, massive icebergs drift like silent, white ships. They sit low in the water, with nearly 90% of their mass hidden beneath the surface, a physical manifestation of the tip of the iceberg principle. Attend to the viscosity of the water. At the near-freezing temperatures of the Icelandic highlands, water is nearly twice as viscous as it is at room temperature. This means the water feels thicker and moves with a more deliberate, heavy grace. As it pours over the edge of a cliff, it clings to the stone for a fraction of a second longer, creating a smooth glass-like curve known as a nappy. This higher viscosity also allows the water to carry more sediment, facilitating the slow carving of canyons like Jökulsárgljúfur, which is 25 kilometers long and up to 500 meters wide. Deep within the turbulence, the water becomes 100% saturated with dissolved oxygen. This process, called aeration, is vital for the aquatic ecosystem. The high-energy environment of the waterfall acts like a giant lung for the river, scrubbing the water and enriching it. This is why the rivers downstream of the falls are often teeming with life, such as the Atlantic salmon, Salmo salar, which use their powerful muscles to leap against the very gravity we are observing, driven by a biological imperative that is as relentless as the flow itself. At this very moment, consider the concept of isostatic rebound. Because the glaciers are melting and losing mass, the land of Iceland is actually rising. In some areas near the center of the island, the ground is lifting by as much as 30 millimeters per year. This is a planetary scale adjustment, a slow exhale of the Earth's crust as the burden of the ice is lifted. The waterfalls you visualize are slightly higher today than they were yesterday, a subtle shift in the balance between the weight of the water and the buoyancy of the tectonic plates. Think of the energy being transformed here. A large waterfall like Waterfalls has a theoretical power potential of about 85 megawatts. That is enough energy to power roughly 15,000 homes. This power is not just a human measurement. It is the energy that shapes the earth, that moves mountains one grain of sand at a time, and that creates the very mists that nourish the moss. It is a constant rhythmic expenditure of the Earth's internal and external forces. As you continue to breathe, allow your mind to drift back to the image of the basalt columns. They are the scaffolding of the island, cold and enduring. The water is the traveler, ancient and ever-renewing. Together, they create a clockwork mechanism that operates on a timescale far beyond the human experience. You are a guest in this landscape of physics and time. The water continues its 122-meter descent. The tectonic plates continue their 25-millimeter expansion, and the ancient molecules of water continue their blue, rhythmic dance. Everything is in its proper place. The universe is functioning exactly as it should, governed by laws that are as comforting as they are immutable. Let the weight of this knowledge settle over you like a blanket of woolly fringe moss, soft and insulating, as you move toward the deeper, quieter currents of the night. As you rest in the sanctuary of your own stillness, the woolly fringe moss of the Icelandic highlands continues its silent, centuries-long expansion, holding the moisture of the mist within its silvery fibers. Picture your own body as a biological mirror to this landscape. The iron that allows your blood to carry oxygen, pulsing rhythmically through your veins, was forged in the same stellar nucleosynthesis that produced the magnetite and ilmenite found in the dark Icelandic basalt. Deep within your marrow, the elements are the same. You are a sentient piece of the Earth's crust, momentarily granted the ability to contemplate the very forces that shaped you. Consider the immense biological patience of the map lichen, or Rhizocarpon geographicum, which clings to the stones near the spray of the falls. Scientists discovered that this organism grows at a rate of only 0.5 millimeters per year. If you find a patch of lichen the size of a dinner plate on a basalt column at Waterfalls, you are looking at a living record that has survived since the High Middle Ages. It has sat in the same spot, enduring 500 years of Arctic winters and the constant vibration of the falling water, growing so slowly that its movement is effectively frozen in time. This is a different kind of clock, one that measures life in centuries rather than seconds, inviting you to release the urgency of your own schedule. Notice how the water behaves as it begins its aqueous descent. At a molecular level, the water in the river is held together by hydrogen bonds, which form at a precise angle of 104.5 degrees. This specific geometry is what gives water its high surface tension, allowing it to cling to the edge of a precipice like Selja for a fraction of a second before gravity wins the tug of war. This surface tension is why the falling water often looks like a series of braided silver ribbons rather than a chaotic blur. It is a microscopic architecture that supports the macroscopic beauty of the falls. What's happening now beneath the surface of the island is a process of geological healing. In a project known as Carbfix, located near the Hengil volcano, researchers are utilizing the unique chemistry of basalt to fight climate change. They dissolve carbon dioxide in water and inject it into the porous volcanic rock 2,000 meters below the surface. Because basalt is approximately 25% calcium, magnesium, and iron by weight, a chemical reaction occurs. In less than 2 years, 95% of that injected CO2 is mineralized, literally turned into solid white carbonate stone. And picture the immense stability of this. The sky being turned back into the earth, a slow, silent transformation that happens in the dark, cool depths of the crust. At this very moment, your own breath follows a similar cycle of exchange, a rhythmic movement of gases that connects you to the atmosphere. The air you inhale has been scrubbed clean by the very rain and mist that feeds the glaciers. In the southern regions near the Myrdalsjökull glacier, the average annual precipitation can reach up to 4,000 millimeters, over 13 feet of water falling from the sky every year. This is the raw material of the waterfalls. Imagine this water as an infinite hourglass, where the falling liquid is the sand, but the glass itself is constantly being blown and reshaped by the volcanic fire beneath the island. The scientists discovered that the glaciers we see today are not as ancient as they appear. During the medieval warm period, roughly between 800 and 1300 AD, many of Iceland's glaciers, including the titanic Vatnajökull, were significantly smaller than they are now. It was only during the Little Ice Age, a period of global cooling that lasted from 1300 to about 1850, that the glaciers advanced to the sizes we recognize today. The waterfalls we observe are the children of this specific climatic era, a reminder that the Earth's features are not permanent fixtures, but temporary expressions of the planet's shifting temperature. Deep within the mechanics of the water itself lies the property of specific heat capacity. Water has a value of 4.186 joules per gram per degree Celsius, which is exceptionally high. This means the water in the falls acts as a thermal stabilizer for the entire island. It absorbs the heat of the summer sun and the warmth of the geothermal vents without changing its own temperature rapidly. This is the same physics that allows your own body to maintain a steady 37 degrees Celsius regardless of the world around you. You and the river share this thermal resilience, a steady internal flame that resists the cold. Observe the phenomenon of thufa, or frost heaves, which dot the landscapes around the falls. These are hummocks of earth and vegetation that can stand up to 1 meter tall. They are created by the repetitive freezing and thawing of ground moisture, which slowly pushes the soil upward in a rhythmic, seasonal pulse. It is the Earth's way of breathing, a slow heave of the crust that takes years to form a single mound. Imagine the landscape as a slow-motion ocean where the waves are made of soil and moss, cresting over decades rather than seconds. Consider the history of Barnafoss, the Children's Falls on the Vita River. Historically, there was a natural stone bridge that arched over the turbulent water. According to local records, the arch was destroyed in the late 18th century after a tragic accident. From a geological perspective, this highlights the fragility of even the hardest basalt when faced with the relentless kinetic energy of a river, moving at several meters per second. The water is a sculptor that never puts down its chisel. It is a patient artist that knows that, given enough time, the softest fluid can defeat the hardest stone. Picture the refractive index of the ice that feeds these falls, which is approximately 1.31. This is slightly lower than the refractive index of liquid water, which is 1.33. This difference is why glacial ice can look so startlingly clear, or, when compressed and deprived of air bubbles, a deep, resonant blue. When you look at the water of Waterfalls, you are seeing light that has been bent and filtered by this refractive journey, a visual manifestation of the water's density and purity. What's happening now is a demonstration of the Coriolis effect on a grand scale. Because Iceland sits at a high latitude, between 63 and 66 degrees north, the rotation of the Earth has a subtle but measurable influence on the way water swirls into the plunge pools at the base of the falls. In the northern hemisphere, this force gently nudges the water in a counterclockwise direction. It is a quiet reminder that the falling water is part of a spinning planet, hurtling through the vacuum of space at 1,600 kilometers per hour at the equator, while we remain perfectly still, held in place by the same gravity that pulls the river over the cliff. Scientists discovered that the sediment moved by Waterfalls is not just rock. It is a vital nutrient source for the North Atlantic. Every day, this single waterfall carries approximately 5 to 10 tons of particulate matter into the Jökulsá á Fjöllum River, which eventually empties into the sea. This sediment is rich in bioavailable iron, which triggers the growth of phytoplankton, the microscopic plants that produce over 50% of the Earth's oxygen. When you breathe in the quiet of your room, you are potentially inhaling oxygen made possible by the grinding of a glacier against a mountain in the Icelandic interior. The waterfall is a vital organ in the planet's respiratory system. Notice how the basalt at Thingvellir National Park, where the tectonic rift is most visible, is approximately 10,000 years old. This rock was formed just as the last great ice age was ending. It has stood through the entirety of human civilization. If you were to press your palm against this stone, you would feel a substance that has remained unchanged while empires rose and fell. It is a cold, heavy anchor in a world of constant flux. In 2010, the eruption of Eyjafjallajökull sent a plume of ash 9 kilometers into the sky. This ash eventually settled on the nearby Seljalandsfoss, turning the white curtain of water into a dark, gritty veil for weeks. But the river did not stop. It eventually cleared the ash, carrying it to the sea and restoring the waterfall to its pristine state. This is the essence of the Icelandic landscape, a constant cycle of disruption and restoration. The water always finds its way back to clarity, just as your mind finds its way back to peace when the distractions of the day are washed away by the rhythmic cadence of the night. The island of Iceland is fueled by a mantle plume, a localized upwelling of hot rock that starts nearly 2,900 kilometers deep at the Earth's core mantle boundary. This plume is estimated to be about 100 kilometers wide and is what provides the heat for the volcanoes that melt the glaciers. Imagine this pillar of heat rising through the darkness of the Earth's interior, a slow-burning battery that powers the entire system. It is the fire that creates the ice, which in turn creates the water, which in turn creates the falls. As you sink further into the support of your bed, let the realization wash over you that you are a participant in this global machinery. Your rest is a biological necessity, a period of maintenance and equilibrium that mirrors the steady, balanced flow of the Hraunfossar rivulets. The Earth does not rush its geological processes, and you need not rush your descent into sleep. The water is falling at 9.8 meters per second squared. The tectonic plates are moving at 25 millimeters per year, and the map lichen is growing at 0.5 millimeters per year. All of these speeds are correct. All of these rhythms are valid. Allow yourself to be governed by these larger, slower laws of nature. As you move toward the deep, restorative silence of the Icelandic night, imagine your anatomy as a biological heat exchanger, mirroring the geothermal systems that pulse beneath the Icelandic crust, where the warmth of your core is regulated with the same steady precision as the planet's internal currents. As we sink into more profound quiet, we must consider the invisible sensory layers that define this northern sanctuary, beginning with the very air that fills your lungs. Scientists have determined that the human olfactory system can detect the presence of certain organic compounds in incredibly minute concentrations. One of the most evocative scents in Iceland is that of petrichor, which is particularly sharp when the mist of a waterfall like Seljalandsfoss hits the parched volcanic ash. And this scent is caused by a molecule called geosmin, produced by soil-dwelling bacteria such as streptomyces. Notice the way your mind associates this earthy, mineral aroma with freshness. At a concentration of only 5 parts per trillion, your nose can recognize this compound, a prehistoric signal that water is nearby. In Iceland, this petrichor is often mixed with the faint, ozonic tang of ionized air, created as the 60-meter drop of the water shears molecules apart, releasing negatively charged ions into the atmosphere. At this precise moment in the Arctic Circle, the sky itself is undergoing a silent chemical transformation. Far above the peaks of the Vatnajökull ice cap, at altitudes between 100 and 300 kilometers, the aurora borealis begins its rhythmic sway. Picture the chemistry of this light. It begins with the solar wind, a stream of charged particles from the sun traveling at velocities of approximately 400 kilometers per second. When these particles collide with the Earth's magnetosphere, they are funneled toward the poles, where they strike oxygen and nitrogen molecules. Notice the chromatic shift in the sky as these collisions occur. When the solar particles strike oxygen atoms at lower altitudes, around 100 kilometers, they emit a brilliant yellowish-green light at a wavelength of 557.7 nanometers. This is the most common color of the northern lights, a soothing neon glow that reflects off the white surface of the glaciers and the dark mirrors of the waterfall pools. If the particles hit oxygen at higher altitudes, above 200 kilometers, they produce a deep, rare crimson at 630 nanometers. This is a slow-motion atomic dance, where energy is absorbed and then released as photons, bathing the waterfalls in a light that is literally celestial in origin. Deep within the sonic landscape of the falls, there is a frequency that you don't hear with your ears, but feel with your diaphragm. Large waterfalls generate infrasound, acoustic waves with a frequency below 20 Hz. While the human ear typically only perceives sounds above this threshold, the body remains sensitive to these low-frequency vibrations. Scientists have observed that these infrasonic waves can travel for hundreds of kilometers without losing their integrity. Consider the possibility that the very bed you lie upon is subtly vibrating in sympathy with the deep 10 Hz pulse of a distant waterfall. It is a planetary hum, a low-frequency lullaby that signals the immense mass of the falling water and the solid stability of the basalt. What's happening now within the water of the Skjálfandafljót River is a display of chromatic scattering. Notice the hue of the water as it approaches Godafoss. It is a milky turquoise blue, a color produced by the specific size of the glacial flower particles. These particles, typically less than 2 micrometers in diameter, are exactly the right size to scatter the shorter blue wavelengths of light, while allowing the longer reds to be absorbed. This is known as Tyndall scattering. Imagine the river as a liquid sapphire, its color a direct consequence of the geological grinding occurring miles upstream beneath the ice. Consider the temperature of the land beneath you. Iceland's geothermal gradient is extraordinarily steep. While most continental crust sees a temperature increase of about 30 degrees Celsius for every kilometer of depth, the active volcanic zones in Iceland can see increases of 100 degrees Celsius or more per kilometer. Picture the mantle plume beneath the island, a column of hot rock rising from the core mantle boundary nearly 2,900 kilometers below. This heat source provides a constant upward pressure, a thermal battery that has been charged by the radioactive decay of elements like potassium-40, thorium-232, and uranium-238 within the Earth's interior. The heat you feel in your own body is a small-scale version of this planetary furnace, a steady metabolic burn that maintains your internal equilibrium. Permit the anatomy to acknowledge the texture of the stones near the water's edge. Some of these are pieces of obsidian, volcanic glass formed when lava with a high silica content, often over 70%, cools so rapidly that crystals cannot grow. This material is smooth, cool, and sharp, a frozen liquid that feels like the surface of a dark lake. Contrast this with scoria, the porous, reddish-black rock that is riddled with vesicles. These holes were once gas bubbles, volcanic vapors trapped in the cooling magma. Because of this porosity, scoria has a very low thermal conductivity, roughly 0.1 to 0.2 watts per meter Kelvin, making it an excellent natural insulator. Much like the blankets covering you, the Earth itself has layers designed to trap and hold heat. Scientists discovered a compelling survivor in this environment, the Arctic tern, or Sterna paradisea. Notice the silhouette of this bird as it glides through the mist of the waterfalls. Every year, these creatures undertake the longest migration of any animal on Earth, flying a round trip of approximately 71,000 to 90,000 kilometers between the Arctic and the Antarctic. They spend their lives in a state of perpetual summer, following the light across the globe. As you rest, imagine the endurance of these wings, which are currently folded in sleep on a basalt ledge, having navigated by the Earth's magnetic field, a force generated by the same molten iron core that powers the volcanoes. Deep within the geothermal pools nearby, life exists in its most primitive and resilient forms. Cyanobacteria and other thermophilic organisms thrive in waters reaching temperatures of 70 degrees Celsius. These organisms use a process called chemosynthesis to derive energy from the minerals in the water, such as sulfur and hydrogen sulfide. If you were to walk near a fumarole, a steam vent, you would encounter the sharp, pungent scent of hydrogen sulfide gas, H2S. The human nose is so sensitive to this gas that we can detect it at concentrations as low as 0.05 parts per million. It is a primal scent, a reminder of the Earth's chemical origins and the volatile power that lies just beneath the surface. Grant your form the freedom to experience the weightlessness of the mist. A single raindrop falling toward the waterfall pool has a terminal velocity of about 9 meters per second, depending on its size. But the mist, the aerosolized particles created by the impact, is so light that it is governed more by the movement of the air than by the pull of gravity. These droplets, often only 0.01 millimeters in diameter, can remain suspended in the air for minutes, drifting on the thermal currents rising from the damp earth. This is the comforting void in liquid form, a space where the rules of weight and mass seem to soften. Observe the phenomenon of cryoseism, or ice quakes, that occasionally echo from the glaciers during the coldest months. When the temperature drops rapidly to -20 or -30 degrees Celsius, the moisture trapped in the soil or the cracks of the ice freezes and expands with such force that the ground literally cracks. This sound is a sharp, resonant boom, a reminder of the immense physical forces at play. Yet, in the presence of the waterfall, these sounds are absorbed by the constant white noise roar, integrated into a single unified frequency that creates a barrier against the outside world. Notice the way the moss, specifically Sanionia uncinata, also known as sickle moss, responds to the moisture. This moss can survive complete desiccation, entering a state of dormant metabolic suspension. When the mist of the waterfall touches it, the cells rehydrate within minutes, resuming photosynthesis almost instantly. This is a biological reset, a return to life that mirrors the way your own body restores itself during these hours of rest. You are clearing metabolic byproducts and reorganizing cellular structures, preparing for the renewal that comes with the dawn. At this very moment, to consider the concept of thermal inertia. The basaltic rocks surrounding the falls have a high density, approximately 3,000 kilograms per cubic meter, which allows them to store a significant amount of heat from the sun during the long Arctic summer days. Even as the air temperature drops in the evening, the rocks remain warm to the touch, slowly radiating that energy back into the night. You are currently leaning into your own thermal inertia, your body heat creating a localized microclimate of comfort within the folds of your bed. The island of Iceland is a giant oceanic heat exchanger, where the cold water of the North Atlantic meets the searing heat of the mantle. Every waterfall is a point of contact in this exchange, a place where energy changes form. As you continue to breathe, let the rhythmic nature of these physical laws provide a sense of absolute security. The chemistry of the aurora, the frequency of the infrasound, and the migration of the tern are all moving in their appointed cycles. The Earth is a perfectly calibrated machine, and you are a vital part of its quiet operation. Allow the mineral scents, the turquoise colors, and the low-frequency vibrations to settle deep into your consciousness as we prepare for the final transition into the softest, most restorative layers of the void. As the low-frequency hum of the Icelandic highlands begins to fade into a gentle, rhythmic silence, we bring our observation to a soft and comforting halt. The vast aquatic machinery of the island is slowing its pace in your mind's eye, transitioning from the thunderous kinetic energy of the falls into the potential energy of the deep, cold ice. We are entering the final stage of our journey, moving from the macroscopic grandeur of the tectonic plates toward the microscopic piece of your own internal biology. Step by step, the process of the Icelandic winter begins to unfold in your imagination. The temperature of the air drops below the threshold of 0 degrees Celsius, and the physics of crystallization take hold. Within the mist of the falls, water molecules begin to align in their preferred hexagonal geometry. This process starts with a single nucleation point, perhaps a microscopic particle of basalt dust. One by one, the water molecules, with their 104.5-degree bond angles, link together through hydrogen bonds, creating a lattice that is less dense than the liquid it came from. Slowly, the spray of Skogafoss turns into delicate rime ice, coating the dark rocks in a translucent white armor. The roar of the water is gradually dampened, muffled by the growing layers of frost, until the river moves with a quiet, heavy grace beneath a ceiling of silver. Notice how the land itself is participating in this gradual retreat into stillness. The North American and Eurasian tectonic plates, which have been pulling apart at a rate of 25 millimeters per year, continue their slow-motion departure, but you no longer feel the tension of their movement. Instead, you feel the stability they provide. You are resting on a crust that is, on average, 30 to 40 kilometers thick in this region. This crust is composed primarily of basaltic rock, rich in magnesium and iron, the same iron that resides within your own hemoglobin, allowing your blood to transport oxygen to every cell in your body. Scientists discovered that the iron in your blood and the iron in the Icelandic stone were both forged in the same stellar furnaces of ancient dying stars. At this very moment, you are a localized concentration of the universe, resting upon a planetary foundation that shares your very chemistry. Picture the step-by-step descent of a single photon of light from the star Vega, located 25 light-years away. This photon began its journey 2.5 decades ago, traveling through the absolute vacuum of space at 299,792 kilometers per second. It has crossed nearly 240 trillion kilometers of void to reach the Earth's atmosphere tonight. As it enters the upper thermosphere, it is filtered and scattered, eventually reflecting off a piece of glacial ice on the Vatnajökull cap. That light, which has traveled for 25 years, now finds its final destination in the stillness of your mind. The universe is a vast network of such connections, an intricate clockwork where the light of distant stars and the ice of the North Atlantic meet in a single, quiet moment of observation. Consider the composition of your own skeletal structure. Your bones are made of calcium hydroxyapatite, containing about 1.5% of your total body weight in pure calcium. This is the same element that makes up approximately 4.1% of the Earth's crust by weight. When the basaltic rocks around the waterfalls weather and erode, they release this calcium into the soil and the sea, where it eventually finds its way into the food chain and, ultimately, into you. You are not a visitor to this planet. You are a literal manifestation of its mineral wealth. The calcium in your limbs is as old as the Earth itself, approximately 4.54 billion years, and it is now seeking the same rest that the stones experience in the depths of the Arctic night. What is happening now is a transition from the external world to the internal sanctuary of sleep. Scientists have measured the Earth's magnetic field at this latitude to be approximately 50 to 60 microteslas. This field, generated by the convection of molten iron in the Earth's outer core, 2,900 kilometers beneath your feet, acts as a protective shield, deflective the high-energy particles of the solar wind. At this very moment, you are being cradled by this invisible magnetic embrace. It is a constant, a reliable force that has guided migratory birds and sailors for centuries, and now it provides a sense of directional peace for your drifting consciousness. Deep within the brain, the pineal gland is responding to the absence of light, a process that has evolved over millions of years. It begins to secrete melatonin, a hormone that signals every system in your body to prepare for restoration. This chemical shift is as predictable as the tides, which are governed by the gravitational pull of the Moon, a celestial body 384,400 kilometers away. The Moon's mass, about 1/81st of the Earth's, exerts a force that gently tugs at the oceans, creating a rhythmic rise and fall of the water levels in the Icelandic fjords. Your body, being approximately 60% water, is part of this lunar rhythm. You are physically connected to the satellite that circles us in the dark. Observe the process of thermal equilibrium. The air in your room is slowly reaching a stable state with your skin. The specific heat capacity of your surroundings allows for a gentle exchange of energy, ensuring that your core temperature remains within a narrow, healthy range of 36.1 to 37.2 degrees Celsius. This is the same principle that allows the deep waters of the Silfra fissure to remain a constant 2 to 4 degrees Celsius year-round, regardless of the storms above. There is a profound safety in this thermal constancy. The world may shift and change, but the fundamental laws of thermodynamics ensure your continued comfort. Notice how your breathing has become a slow, rhythmic cycle of gas exchange. With every inhale, you take in a mixture of 78% nitrogen and 21% oxygen. This oxygen was once part of the global cycle of photosynthesis, perhaps released by the phytoplankton in the North Atlantic that were nourished by the sediment of Detifos. With every exhale, you release carbon dioxide, which may one day be mineralized into stone by the basalt of the Carbfix project. You are breathing the Earth, and the Earth is breathing you. You are an integral part of the 13.8 billion year history of the cosmos, a brief and beautiful expression of its infinite complexity. As you drift closer to the threshold of deep sleep, let these affirmations of the cosmos settle into your mind. You are made of the same elements as the stars. Your body is governed by the same gravity that guides the rivers. Your rest is a fundamental part of the Earth's cycle of renewal. You are protected by the magnetic fields of a spinning planet. The calcium in your bones is as ancient as the mountains. The iron in your blood is a gift from the hearts of dying stars. Your breath is a bridge between you and the atmosphere. The silence of the void is a comforting blanket. The universe is functioning with perfect rhythmic precision. You have a right to be here, and you have a right to rest. The water is still. The ice is patient. The stones are enduring. The stars are constant. The darkness is a sanctuary. The weightlessness of the void is your natural state. Every cell in your body is entering a state of repair and peace. The kinetic energy of the day has been converted into the potential of the night. You are safe in the arms of the laws of physics. The Earth is rotating at 735 kilometers per hour beneath you, but you are perfectly still. You are a piece of the universe experiencing itself. You are home. The mist of the eternal waterfalls has settled. The basalt columns are cold and silent. The glaciers are holding their breath. The aurora has faded into a soft velvet blackness. The entire island of Iceland is asleep, and you are asleep with it. The journey is complete, and the destination is the profound, restorative silence of the void. There is nothing more to observe, nothing more to understand. There is only the steady, rhythmic pulse of the planet and the deep, warm interior of your own dreams. The hydrogen bonds are holding. The tectonic plates are resting. The light from Vega has found its home. The calcium and the iron are at peace. Good night.